Yes, sir. Pleasant morning to one and all. On behalf of Sri Chandraprabhu Jain College, I welcome you all to our sixth day faculty development series on recent trends in chemistry, organized by Department of Chemistry. Today's core topic is Emerging Trend in Chemistry by Dr. S. Jacob, Assistant Professor, DST Inspired Faculty, Young Scientist, Loyola College. Welcome, sir. Welcome the gathering is always a great tradition. For that, I request our senior faculty, Dr. G.P. Bhavani, Head Department of Chemistry, for welcome address. Bhavani ma'am.
Yes, ma'am. Thank you, ma'am. Honorable Chief Guest, respected management, respected principal, vice principal, professor, all my dear friends and my dear students. Good morning to one and all present here. It's give me a warm welcome for everyone present today, FDP and STTP. A very special welcome to our Chief Guest, Dr.M.Jaccob, Assistant Professor, TST Inspired Faculty, Young Scientist, Loyola College, Chennai. My great thanks to accept my invitation to deliver your special topic, sir. I wish to all you today as your sixth day program. Thank you, sir. Once again, I welcome you all. Thank you, ma'am.
Thank you, ma'am. As ma'am mentioned, thanks for accepting our invitation, sir. Welcome to our esteemed institution. Welcome you all. It's time to know about our chief guest profile. Let's brief in a short term. Dr. M. Jacob, Assistant Professor, DST Inspired Faculty and Young Scientist at Loyola College. His graduation is BSc Chemistry and he is postgraduated in MSc Chemistry and scored as third ranking in his PG and has completed doctorate in chemistry. He started his teaching career as a project fellowship at Bharatidasan University during 2008. Further, he worked for IIT Bombay, NIT Trichy, and from June 2013 to till date, he associated with Loyola College as an assistant professor and as a DST inspired young scientist. He published more than 50 national and international journals. His work and contribution to the field of chemistry helped so many scholars to refer his work for a citation. He also organized more than 7 workshops and seminars under his supervision. He been as invited as a chief guest and a guest speaker for more than 17 programs. Not only this, he also attended more than 16 seminars and workshops. More than 22 research papers published and presented by him. For these many contributions, he awarded honored with various awards. Few of them like DST Inspired Faculty Award, DST Young Scientist Award, DST and CSR Travel Grant Award for attending Board International Conference at Spain. It's for sure that, without any doubt, certainly we have an eminent chief guest among us today. Sir, we really feel privileged and proud to be a chief guest for you today's seminar. Sir, welcome you, and the session is yours.
Thank you, ma'am. Thank you for your nice introduction. Am I audible?
Yes, sir.
Yes, sir. Audible, sir.
Shall I proceed, ma'am?
Yes, sir.
Thank you for the organizer giving me the opportunity to share my experience in the field of chemical science. Today, what I am going to deliver on essences and nuances of chemical science. Okay, in which whatever we are learning in terms of chemistry, what way we have to learn the chemistry aspect. When we are studying in the school, normally we fear about the chemical reactions. Most of the students, even still now, the most of the third year BSc students are afraid about writing the mechanism and other aspect. But today I am going to elaborate on in what one can talk in terms of studying chemistry, and then they will also learn in what way they have to understand the basic concepts of chemistry. That's what today I'm going to talk. My screen is visible.
Yes, sir. Visible, sir.
Yeah, is it visible now? Okay. So, what are the essences and nuances, the basis of chemical science? So, the chemical science is evergreen in our life. Without chemical science, you can't have the chemistry. There are a lot of books in online. If you go through chemistry for breakfast, whatever happening right from morning, you get up from the bed and then up to eating the breakfast, whatever happening in the chemistry in our life, that is written in the book called The Chemistry for Breakfast, The Amazing Science of Everyday Life. Dr. Maiti Nuan, he written the book on this, and then the essence, a charming rom through the essence of chemistry. If you go through the book, what will happen? The melatonin, that is very important for our sleep, and then there will be atropine. There will be a immunity booster when you get the proper sleep up to night 10 to 4. There will be a simultaneous hormones which will be segregated in our body. If you are not getting adequate sleep, ultimately you will not get the enough immunity on your body. So the chemistry is all about uh, what we will do in everything in a proper manner. Then only we can enjoy our life. Similarly, in the chemistry also, if you do it in a proper way of learning, then you can enjoy in learning the chemistry. Otherwise, learning chemistry will be the difficult job. So the another book you can see here, the right side, the nature of chemical concept, the reconstructing chemical knowledge in teaching and learning. So these are all the books I taken only few instance where I can inspired from the books. So from that I am going to explore myself in what way I will teach to my own students when I am teaching quantum chemistry, thermodynamics, statistical thermodynamics, group theory, electrochemistry. In thermodynamics, there are three aspects: classical, chemical thermodynamics, and then non-linear thermodynamics. In all the cases, the people will feel very difficult in understanding the mathematics as well as the physical concept because we never know what is a way. If you want to friend of someone, ultimately what we will do, we will try to know about your own friends. That's what our way of doing relationship with anyone. If I want to have a good relationship with my father, my mother, to everyone, I need to know first who are they, how are they, what they will react when they have the different kind of situation. That's what we are studying in terms of chemistry. There are 119 elements so far. Out of 119 elements, whatever the properties which is going to happen, there are four types of chemical concept. From this book, you can conclude there are four types of chemical concept where you can study everything in it. For example, the objects, that is a kind of things existing in the physical world. If you talk about in terms of chemistry, it is a element. If you talk about in terms of human life, it is a humans. If you talk about in terms of animal kingdom, the animals. So these are in terms of if you talk about plant biology, the plants. So this is what the object, the kind of things exist in the physical world where uh, we are our perception towards these object. The object can be sulfur, nitrogen, hydrogen, oxygen, copper, anything. But the kind of thing exists in the world, that will be a chemical concept. Everything, the mobile is made up of the silica, and then the cover is made up of the plastic material or fiber material, the carbon material. Everything is made up of chemistry. Even at the end of the day, if you burn ourselves, Ultimately, what will happen? You will get the carbon. We are inhaling oxygen, carbon dioxide is coming out. By the way, there will be a sucrose or a fructose or glucose is getting into converted into CO2 and 7 ATP, 14 ATP, ADP, all the things which is concerned. So the first ever concept is object, the kind of thing exists in the world. I request all of you, even the faculty member also, we should know the entire elements name, the periodic table. So the element, the entire elements, their name at least, and then how many electrons and all other concept. If you know about this, then only you can enjoy the chemistry. Without knowing anyone, how can you have the friendship? Anyone can go or can plan journey without know where to go. So similarly, if you are a chemistry student, you should know what are the elements. That is 119 elements. If you never know these 119 elements, ultimately you are wasting your time in studying the chemistry. Because what I am telling exactly, see, if you want to know the chemistry is all about 119 elements. The peculiarity, the uniqueness, the properties of all the 119 elements. The second one, events. The events is nothing but melting point, boiling point, sublimation. All the other concept will comes under the events. Then the qualities, the properties, electronegativity, electron affinity, uh, then they will lose the electron, they will accept the electron. As far as my concern, the chemistry is all about give and take policy. The entire chemistry concept which comes under the clear picture of give and take policy. Other than that, all the properties which is comes under give and take policy. And then finally the meta concepts which is comes under all the basic principles. The principles, Lee-Chatelier-Brand principle, Avogadro principle, whatever the principle you are studying, Gay-Lucas law, Avogadro law, Charles law, whatever the principles, whatever the concept you are comes under, they are comes under meta concept. So what I am suggesting you, that if you want to know the nuances or basic essences of chemistry, one should know what I am going to study. Second one, we should know about the fundamentals. The fundamental is all about if I am belonging to some family, my father name is Madhavan. I should know what is my father, how is my father, how is my mother, the entire my own brothers and sisters. Then only I can have a good relationship and happiness throughout my life. Otherwise, it will be the waste of time in spending no time on all the things. So what I am suggesting you, my dear friends, please learn chemistry. Before learning chemistry, you should know you are learning about the fundamentals of 119 elements. This is what the entire aspect. Okay, please remember you are going to learn about 119 elements and its property. Other than that, nothing. Okay. 1 minute. I will share the screen. Yeah. Now, who? So, as I told you, the first step, the chemistry is all about 119 elements. Okay. Now I know the object which I am going to learn. The second one, what I am going to learn. I need to know the sum of the property. See, the properties all belongs to, this is what? Atom, which is having the, which is giving the model. The model is the best, well known, well accepted model is Bohr model. And then this model also, the other model is also known as electron cloud model. And then they have the elements, that's what 119 elements. They can have a different kind of mass number and atomic numbers, the same atomic number but a different kind of mass number, they can call it as isotope. The structure of atoms, they have the neutrons, they have the protons, they have the electrons. Electrons are negatively charged, neutrons are neutral, protons are positively charged. So they have the sum of this, which is wrongly mentioned. The neutron have a negative charge. Electron have the negative charge, neutron have the neutral charge. So this atomic number is all about number of protons. The electron is nothing but the negative charge. The sum of the electron or proton is known as mass number. These are all the things we should know. This is the fundamental. If you know this fundamental, ultimately you will enjoy in learning the things. Okay, there are three major species of elements, that is neutron, proton, and then electron. These all, most of them present in nucleus. Nucleus is positively charged. So these positively charged nucleus present in the center of the ring, and then the electrons are revolved around the nucleus. This is known as orbit. Each orbit has the specific energy. This is concept of Bohr theory. When the electron jump from one orbit to another orbital, there will be a known as excited state. This can be done by giving the quantum of radiation. So the quantum of radiation upon giving that the electrons are ejected, electrons are excited from ground state to first eye-laying excited state, sorry. Then after some point of time, it will come down. This is what absorption and emission. Now the electrons are negatively charged. Okay, then the neutrons are neutral charge, proton positively charged. Okay, now the students always have the problem, for example, if you have the question like that, nitrogen and oxygen. Nitrogen have the atomic number 7, 14, 8, 16. Okay, now if you take these two elements, the ionization energy, there are properties. I told you I'm talking about the object. Now I'm going to talk about the property, ionization energy, electron affinity, electronegativity, all the things come together. These three properties are the major aspect in chemical reactivity. When you talk about the chemical reactivity, these three things are very, very important. Now I will come to the point. What is ionization energy? Boys, please try to understand. The ions can have a positive or negative charge. ionization energy. So the energy is required to form the ions. How will form the ions? For example, if you gain one electron, you are gaining one electron. You are losing one electron. In chemistry, if you gain one electron, it will have a minus sign. If you lose one electron, it will have a positive sign. This is what the sodium can lose one electron. Hello? Hello, madam? Madam, no, talk let. Sodium, okay. Sodium, if it is loses one electron, loses one electron, ultimately what will happen? What will happen? Because it forms sodium plus. If you take fluorine, F minus. So in chemistry, if it is gaining the electron, which occur minus charge. If it is loses the electron, it occur positive charge. Very clear? So the gain positive charge, gain negative charge, lose positive charge. Okay. This is other way it is known as reduction. It is other way it is known as oxidation. Simply they will say Leoger. Loss of electron, oxidation, gain of electron, reduction. This is what the symbol term which illustrate the concept of oxidation and reduction. Okay. Now if you take sodium which is having the 11 electron, which is loses 1 electron and have the 10. So what is the process? The nucleus, the positively charged. There are so 2n squared formula. N is the number of cell. If n is equal to 1, 2, n is equal to 2, 8, n is equal to 3, 18. So these are all the number of electrons can accommodate in the particular shell. If n is equal to 1, this formula is called the four-berry concept, the K shell, L cell, N cell. Okay. Now the sodium loses 1 electron. This energy is required to remove the electron from the outermost orbital, which is known as ionization energy. Ionization potential or ionization potential. Now, this energy required to remove the electron from the outermost orbital. If you take the chlorine, the similar figure I am drawing. So there are 7 electron here. Okay. If you occur 2, 10, 18, 36, these are all noble gas configuration. Any element can try to occur the noble gas configuration because they are stable. So what will happen? The fluorine gains 1 electron. Chlorine gains 1 electron, and then it becomes chlorine 18 minus. This is known as electron affinity. The affinity means love. So the affinity to attract the electron towards it. that is known as electron affinity. Most of the students have the problem. What is the difference between electron affinity and the electronegativity? Electron affinity is a inherent property of an atom. What is inherent? It is tanitanmai. In Tamil, in English, other way it mentioned as uniqueness. The uniqueness of an atom. But the electronegativity is a property of an atom when it is connected with the another atom, that is a molecule. When you have the molecule, for example, hydrogen chloride, hydrogen fluoride, in the molecule, the chlorine have the higher affinity to attract the electron towards it. That is the bonding electron. The electron, which is mutually sharing of electron, that is known as covalent bond. I am talking more concepts. Even it is very pertinent to the first year, second year BSc students because they are learning. So the mutually sharing of electron. Hydrogen gives one electron, chlorine gives one electron. So they form the bond. If you want to make the line, you need a two dots. Similarly, if you want to form the bond, chemical bond, you need two electrons. The two electron comes from each one of the atom. Each of the atom, this is known as covalent bond. So what is happening here? The entire electron density of the particular bond is concentrated towards the fluorine atom, and some less electron density concentrated on hydrogen atom in hydrochloric acid. So because of this reason, this property is known as electronegativity. So electron affinity is a unique property of an atom. Electronegativity is the property of an atom which is connected in the molecule. Okay, this is what very clear. Now the people have the question like this. The 7N14, that is a nitrogen molecule, have higher ionization potential than oxygen. The first ionization potential. This is a question they will ask you. For nitrogen, the atomic number 1s to 2s to 2p 3. So the 2p3 have the 3 electron. For oxygen, only one difference, there are one more electron. Okay. Now, what is happening? This half field is more stable than one electron in the half field configuration. So what is happening? This electron is removing electron from the oxygen is much easier than the nitrogen. But the second ionization energy will be much more higher in the case of oxygen. So these are all the basic concepts. What is happening for the students? Always they forget the same charge will repel each other. Electron will repel each other. That's why there will be a law called Pauli's exclusion principle, mutual exclusion principle. Inclusion means I'm including. If you have the one electron, I have 4 electrons. The fourth electron can have the reverse spin, not the same spin as we have. Why the electrons are not filling with the same spin? Because of the same spin will repel each other. So this is way, other way it is called no two electrons can have all the 4 quantum numbers are identical. Madam, shall I proceed like that? Is it okay, ma'am? Ma'am?
Yes, sir, yes, sir, you can proceed.
Shall I proceed, ma'am?
Yes, sir. Proceed, sir.
Okay.
Fine, sir. Fine.
Okay. Now, see, what is quantum number? Next one. If it is a direct class, I can have a more interaction, but unfortunately, we don't have anything. The streaming. There will be a N, L, M, S. This is a principal quantum number, orbital quantum number, azimuthal, and then magnetic quantum number, and then spin quantum number. The principal quantum number, the energy state. Orbital quantum number, shape, orientation. This is the orientation. This is the shape of the orbital. This is the inherent property. As I told you, this would be the inherent property of an atom. Sorry for not writing properly. Energy state. So N can have a 1, 2, 3. L can have a N minus 1 value. They have a 2L plus 1 orientations. And then they can have a plus or minus of. This is what the basics of chemistry. That's it. If you know these basics very well, you can enjoy anything. Don't bother about other concept, the chemistry, all other things. This is what the basis of entire chemistry. Okay. As a quantum chemist, I know I completed my BSc in 2003, MSc in 2005. From 2005 till now, I am doing research in the field of theoretical and computational chemistry. The computational chemistry is all about using the quantum chemical principle and try to solve the chemical problem. Okay, so now you should learn all the things easily. Now you come here. I will teach you from the basis of periodic table. I will teach you all the fundamentals. Okay. Wait, I will share my entire screen. Then that will be the better for me.
Ma'am, Gauri ma'am, shall I proceed?
Yeah, my
Ma'am?
screen is visible.
No, sir.
No, sir, your PPT and the screen is not
Just now
visible.
disappeared, sir.
Now I shared my entire screen.
Once again, you install your screen, sir.
Yeah, now is it okay, ma'am? Screen is visible.
No, sir.
You pin the my own screen. You instead of pinning the my video, pin the entire screen. Okay. Wait. Okay. Now come to the basis of chemistry. So the object kind of things exist in the physical world. That's what 119 elements. The event I told you what are the process in chemistry. Now I'm going to talk about the process in chemistry. Okay. Now you can see, my dear students, if you take any one particular element, okay, one particular element, and then for example, salt, the table salt, what we are having in our home. So I told you earlier, the chemistry is all about give and take policy. I will connect from here electrophile, acid, and then I will come one by one. Okay. Now, if you take the periodic table, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So keep on going. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. We keep on going like that. Sodium, magnesium, calcium, strontium, radium, everything. Boron, aluminium, gallium, indium, carbon, silicon, nitrogen, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, fluorine, chlorine, bromine, iodine, astatine. Okay. If you take these, the periodic table, the entire human tried to become rich. They wanted to become
Sir,
a.
may I know, are you share any screen, sir?
Yes, ma'am, I shared my screen.
No, sir. Not visible, sir.
What is happening here?
Yeah, yes, sir.
I'm shared screen. No, ma'am.
No, sir. Yeah. Yes, sir, visible, sir.
Earlier, whatever I spoken, it's not visible, isn't it? Okay.
Just oral. Yeah. Yes, sir. Now, okay, sir.
I will take care. Okay. Sorry.
Yeah, yes, sir. Thank you, sir.
Yeah. Now you can see here the chemistry is all about give and take policy. I will correlate with the human, our own, what we are thought of doing in our life. We always intend to become rich and try to earn more money. This is what our thought. But in our circle, the 119 elements are present in the earth crust. All the 119 elements, out of other than noble gas metals, they are trying to acquire the noble gas configuration. That is the most stable configuration. Most stable configuration ever. They try to acquire the completely filled configuration. Helium, neon, argon, krypton, xenon, radon configurations. So what is happening here? The hydrogen is a peculiar, hydrogen having only one atom, one electron. If it is loses, ultimately what will happen? It form proton. This what? Proton is, there is no electron in proton. It is a positively charged which doesn't have any kind of electron at all. Smallest species in the earth crust, and it is highly reactive because it doesn't have any kind of electron. Okay, now what is happening here? The fluorine have 9, 8, 7, 6, 5, 4, and then 3. So what is happening here? The charge itself you can manage. Most of them are fail to remember the charges because the first ever concept, they never know what is the elements which is I am going to talk, or what are the elements which is present in the periodic table. They never know. Without knowing this, how can you remember the charges? If you remember the charges, then only you remember the molecular weight. If you remember the molecular weight, then their combinations will be coming under. If you know this, then equivalent weight will come under. All the things which will be based on 119 elements. That's what I told you. If you want to have the friendship with your own friends who is studying along with you, you should know what they are, who they are, from where they coming, what's their family status, everything you should know. Their property, their emotional status. When they are coming along with you, when you are traveling along with the train or bus or a plane, how they are spending their money, how they are behaving in different kind of situations. These all the things which will give you the overall impression about the particular person. Then you feel very secure about them, and then you will have a proper friendship with them. If you don't feel very comfortable with you, whatever the attitude, whatever the property, whatever the behavior you are having, then ultimately you don't feel very comfortable with them, and ultimately you don't wanted their relationship at all. This similarly, the chemical elements have that similar kind of property. What they are trying to become, they are trying to become the configurations of noble gases, because they wanted to be very very stable. Even what we thought to be, we thought to be very comfortable in our own way. Similarly, the elements are wanted to be very comfortable by acquiring the noble gas configuration. That, by the way, the charges and their property and their chemical reactivity, everything is solely decided by the how many electrons they are losing, how many electrons they are gaining by acquiring the noble gas configuration. That's it. This is the basis. Now you come here, the lithium. If you lose just one electron, ultimately it occurs the noble gas configuration of helium. That's why the alkali metal have the electron charge, the valency. The valency is nothing but the electron present in the outermost orbital. In Tamil, it is known as ஒரு அணுவின் இணைதிறன் கூட்டில் உள்ள மொத்த எலக்ட்ரான்கள். இணைதிறன் கூறு, that is known as valence orbital. Okay, so similarly the beryllium, which is having the 2 plus, so that only all the alkaline earth metals have the positive bivalent. This is a univalent, this is a bivalent. So my dear friends, if you really wanted to learn chemistry, try to know the periodic table. You can't remember all the thousands of 119 elements, charges, properties, all other things. We have to have the perception, we have to have the assumption based on their properties. Now, the fluorine, if you gain one electron, so that it is have a minus charge. If you gain 2 electron, it is a 2 minus. If you gain 3 electron, 3 minus. If you gain 4 electron, it is 4 minus. But boron, nobody is ready to give 5 electron. So that what is happening here, it is loses 3 electron, and it is become 1s2 electronic configuration, and it become helium electronic configuration. So that you can see here, beryllium, boron 3 plus, carbon, that is a methane, BCl3, NH3, H2O, and then hydrogen fluoride. So this is what the valency of the electron. So what is happening here, since which is having the vacant orbital, it can have the gaining aspect because it is vacant, but which is more electron density, they have the completely filled electron, so it can lose. So it can, what is happening here, the gain of electron, which is having electron efficient, so that they are known as electrophile. Since it is gain electrons, they have the acid. That's why, which is known as Lewis acid. Ammonia, which is having the lone pair of electron, that's why it is known as Lewis base, which is having the completely filled as well as electron rich. They can act as the nucleophile. Nucleophile means they have more electron, so nucleus means plus, that is a nucleus loving. Electrophile means electron loving. That means that there is no electron at all. This is what the basic. So in other way, you can also call this, if it is take the metal, the electron removed from the metal, so that they have the positive character. They can acquire the positive character. That's why they are electropositive. But the non-metals, which is acquire negative charge by gaining the electron, so that they have the electronegative character. Since it is losers, they are electro nucleophile. So this is the basis of chemistry, where you can enjoy all the things. When you come here in terms of chemistry, it is gains electron, fluorine, it's gain electron, and then they can act as an electrophile. If you come here, the reactivity, if you take, this is a HOMO, this is a LUMO. So you have the filled orbitals, you have the empty orbitals, occupied orbitals. The simple manner, this is a basis of molecular orbital theory. Two atoms, hydrogen and hydrogen, which is having the 1s1, 1s1, combined together, they form the bond. This is 1s2 sigma, sigma 1s2, sigma star 1s2. So what is happening? They have the low, they can combine together and they can form the sigma 1s2. But here they can form the different kind of notations. This is what the basis of antibonding. This is known as antibonding. This is known as bonding. This is a simple molecular orbital. So similarly, they have the molecules. They can filled, and then they have the. This is highest occupied molecular orbital. This is lowest unoccupied molecular orbital. So in other way physics, this is a valence band, this is a conduction. So what is happening? This electron can remove. Otherwise, this electron go up. So this, if it is go up, this is HR, this is known as absorption. If you remove the electron, this is known as ionization energy. Okay, so this is what the basis of entire nanoscience, nanophysics, conduction band, solid state physics. Now come to the concept other way. See, the basic structure of matter, which is have the gases, which is have the solid, which is have the liquid. The basic structure of matter is made up of atom. If you talk about the atomic model, that is microscopic property, that is a 10 power minus 6 to 10 power minus 9, that is 1 by 10 power 6 divided by. So what is happening? When you take atom, ultimately what is happening? These branches is known as quantum chemistry. When you talk about the bonding nature, this is chemical bonding. This is a concept of chemistry. When you take ionic bond, this is ionic bonding, where you are studying the ionic system, that is a sodium chloride, cesium chloride, all the things you are studying. The other way it is known as solid state chemistry. Then when you take ionic property, the polymer chemistry, when atoms combine together to form molecule, when it is loses the electron, ultimately it is known as ultimately what is happening here, it is known as ions. When it is loses the electron, they can have the ionic equilibrium, that is ionic equilibrium, and then all the concept, physical chemistry concept will come, that is pH, POH, all the concept we will study here. When you take molecules, that are also molecules of polymers, also the polyethylene. If you take ethylene molecule combined together, which is having the polyethylene molecule in a larger scale. So this is what the polymer. And then when you come here, gases, the phases. The phases separate the distinct identity of an atom. Very fast solid, they have the crystalline and amorphous, that is a X-ray crystallography. When you talk about their morphology, the structure, the morphology is all about in chemistry. It is stereochemistry and the group theory, their symmetry property. So, Princey, the charger on money. Okay. So now I'm even coming in deeper manner. You can see here the atom, which is consisting of electron, here electron, proton, neutron. These subatomic particle combine together and try to study these concepts, which will give the basis of the chemistry. So when you study the chemistry, you should know. See, with the periodic table itself, you come here electrophile, nucleophile, electron rich, electron deficient, and then acid base. Now another one. See, then what I am going to, very important concept, oxidizing agent, reducing agent. So what is the difference between oxidation and oxidizing? Oxidation means loss of electron. Very clear. Oxidizing means make others to oxidize, makes others to lose. Others to lose. Itself gain. That means they should have the empty orbital. They should have the empty orbitals. Okay. What is mean by reducing? I will change the color of the pen. What is mean by reducing? They will make others to gain. Others. But itself lose. So if you take the example of KMnO4 platinum nitrate, so this is a nickel nitrate or nickel H2. In all the cases, what is happening? The Lingler catalyst. Okay, all the cases you can see manganese. As I told you, this is a +1 charge. This is a -2 into 4. So manganese have the +7 oxidation state. The atomic number of manganese is 25. So argon 18, 3d5, 4s2. What is happening? All the 7 electrons are gone. That's why the KMnO4 have the empty orbital. They can oxidize others, but itself they can have the empty orbital to gain the electron from others. That's why you have the some of the reactions which is happening. KMnO4, oxalic acid, all other things you can take it, and then you can have a 14H plus. What is happening? There will be a 7H2O, M1O2, and then K2SO4, all the things which is comes under. Because these M1O4 in acidic medium, they can lose 5 electron. In basic medium, these are all the basis of this particular aspect. So what I am suggesting you, the electrophile, electron deficient. So electrophile, electron deficient, nucleophile, that nucleus loving. Obviously, if it is nucleus buying, which is having more electrons. If the electrophile, which is electron deficient, obviously, which is having the less electron. That's why bromine plus, which is no electron, less electron, so they can act as a electrophile. So electron rich, electron deficient, acid base, oxidizing, reducing agent. In all the concept, how will you learn? If you know about 119 elements. This is what the first ever conclusion. So I told you kind of things exist in the physical world, that is the 119 elements. The processes, I told you what is happening, the properties, and then chemical concept. Okay. I still go with the concept. See, in entire chemical composition of living cell, you can take it ring glucose, glutamine, D-glucose, insulin, triacylglycerol, DNA. These are all made up of single atoms. What is that? Carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. Very rarely phosphorus and sulfur. These all four put together, and they are making our life very, very easier, very selective and easier. Before that, I will come here. You can take here the polar covalent bond is the electronegativity different from electronegativity. What is electronegativity? I told you electron accepting. It's quite different from metal, which is having the and the non-metal. Metal which loses the electron and the electropositive, non-metal are electronegative. So ionic bond, which is between the shared pair of electron, the give and take policy, they can, for example, the best example table salt. When you come to the covalent bond, there will be a occurs between the two non-metal, the shared pair of electron, and then they can form the acted rule. The lone pair, which is having the individual electron, which is not coming under the things. So the double bond, which is a comes under all the things. Now this is a Holly's concept map, where this particular paper, chemical education research practice, where they have published this one, and then they can have the particular concept called chemical education practices. No, in which you can have the majorly the concept called electronegativity, and also other more important concept I wanted to bring you here, the polarity. and the other way it is known as dipole movement. What is mean by pole? Pole means in Tamil Duruvangal. So there will be a movie also called Iru Duruvangal. So they are the corners. What is the corner which is happening here? One is a positive corner, another one is a negative corner. So what is happening here? When you take the molecule CH4, there is no difference in the electronegativity. If there is a difference between the two atoms, 1.5 less than 1.5, they are not polarized. More than 1.5, they will be polarized. So similarly, when you take hydrogen chlorine, the electronegativity is much more higher for chlorine than the hydrogen. So 90 percentage of the electron density surrounded by chlorine. So they become negative charge and then they become positive charge. Because of this, there is a charge separation, there is a distance enhancement. This known as dipole. Dipole moment is due to the charge separation and the distance. So the charge, it's a coulomb, this per centimeter. So normally the centimeter inverse or Armstrong. So come here, all the organic chemistry, these four elements, when you take the first in 12th standard, CH4, the next unit called halogen, halides, alkyl halides. Next one is ROH, that is alcohol. Another one is ether. The next one RNH2. Then RCHO, RCOR, RCOOH, RCOOR, ester. And then there will be a called RCO amide, NHR. So dash. Similarly, it will keep on going. Now come here from methane to, yeah, come here from methane to RCl. There will be a charge separation. Then if you come here ROH, most of the reaction which will comes under here. In chemistry, you can either break the bond by giving the energy, thermal or photolight. But here already this polarized, the dipole moment is much more higher, so that they can have a charge separation. Then ROH, then ROR, most of the bond cleaved here, either it's tertiary or other things. Then when you come to the carbonyl, there will be a most active resonance. So this lone pair can come here, and then this is a most acidic proton. That's why still now most of the naming reactions comes under aldehyde. Simply it is known as carbonyl compounds. Carbonyl compounds. All the basis is pertaining to polarity. All the things which is nothing but dipole. So if there is a difference, obviously there is a difference opinion, because for example, if the participants of 190, some of them can feel these all the basic concept what Jacob sir is talking. Some of them have the okay, these are all very fundamental, one should know that way, because some of them can have a perception that I learned a lot from today. Some of them are new to them, they learned the entire chemistry in a different manner. So this is what the perception. This perception is other way it is known as polarity. If you change the polarity, ultimately the reactivity will be higher. So the reactivity, obviously, all the reactivity which is related to polarity, the properties, the quality which it decide the polarity. The polarity which comes under dipole moment. Because of these concepts, if the compound is more polar, they are highly reactive. When there is a charge separation, there is a difference in the opinion. Ultimately, there will be a lot of discussion, lot of new invention will come. This is what you can see here, the nature of chemical concept they given the dipole. I have covered everything here. Whatever I have discussed, I thought of giving the concept. Now come here. This is a percentage, the most abundant elements in the living tissue. Hydrogen, carbon, nitrogen, oxygen. This is where the entire our body having the hydrogen, carbon, nitrogen, and then there will be a sodium, magnesium, potassium, phosphorus, sulfur, chlorine, potassium, calcium. These are all very limited. Without these elements, we can't sustain. So when you put together carbon, hydrogen, nitrogen, this is known as organic chemistry. When you put organic chemistry, the major reactivity concept will come under polarity. Everything will talk about the electron, how the electrons are shifting. This, for example, if you take the bond needed 2 electrons. The 2 electrons can combine together and form the bond. If we break homolytically, it will lead to form the radical, 2 radicals. Similarly, if you break the bond heterolytically, then it will lead to form M plus X minus. That most electronegative elements acquire the negative charge, most electropositive elements acquire the positive charge. This is what the basic. Most electronegative element which is having the higher electronegativity, most electropositive element which is having the higher ionization. This is what the entire basic aspect. With that, the entire organic chemistry will come center. You can see here CHO and N. Often, some of the time, sulfur, chlorine, other things will come. But most of the time, these 4 elements are coming. Okay. So these are all the various part of an atom with the distinct element, the smallest particle of an element. I told you all the things atom together, how the valence electron combines together. I drawn all the pictures, the covalent and non-covalent bond. The atom combined together, they form the sharing of electron. If it is a form the ionic bond, the transfer of electron. That's what I told you. The sharing of electron, which is having the mutual sharing of electron, but here they will transfer the electron from one atom to another atom. By the way, one atom loses, another atom gains. That's what it is known as give and take policy. Okay. Now these are all you can take any Nobel Prize in chemistry, in physics, which comes in the field of atomic physics. All the concepts are Nobel Prize winners. Right from Planck, Einstein, Bohr, Compton, de Broglie, Heisenberg, Schrödinger, Pauli, Born. All of them got the Nobel Prize for their invention. What is the concept? Quantization of units, quantum mechanics, Compton effect, de Broglie, quantum mechanics. Now, what is mean by quantum? What is mean by quanta? Quanta means photon of light. Simply, I can say the kundan. If I ask often to my own students, if I have the room full of biryani, how much you can have? Some of them say I can have 5 plate biryani. Some of them can say 3 plate. Some of them can say 2 plate. Some of them can say half plate. But few of them can say whatever substantial for my stomach. Whatever substantial for my stomach. எது என் வயிறுக்கு போதுமானதோ அந்த குவாண்டிட்டி, அதுக்கு பேர் தான் குவாண்டம். ஸோ தட் இஸ் அதர் வே இட் இஸ் நோன் அஸ் discrete amount of energy. What is known as discrete amount of energy? The discrete amount of energy is known as specific energy. Other way it is known as specific energy. This is what you can see here in earlier 19th century. There is a problem in wave particle duality. The people are talking, some of them have the particle nature, some of them have the wave nature, so they can have the property. Okay, now one more thing I will wanted to tell you. So here when you have the bike, you have bike, many of us have the bike. You are due to you don't have the enough parking place, you wanted to park in a safer place in without sunshine, but unfortunately what is happening, you don't have the place to get park your vehicle in a safe place. You are parking your bike in an open place around 11:30. Now exactly 12:10 you are parking there. After half an hour you are coming back and you are taking the bike. What is happening, your bike will be the seat and you are going to sit, which is very hot. So what is happening, the people are trying to give the plot, that is a plot. What is a plot? Whatever the heat absorbed by the your bike seat, the bike seat which is absorbed the heat, the number of radiation and the in terms of frequency. So what is happening? There will be a peak. The same peak, if I kept the bike in the morning 6 o'clock, what is happening? There is no much temperature, the intensity is much less. But if I keep on increasing around 3 o'clock in the mid of the sun, what is happening? There will be a shift in the things. But mathematically, what is happening? The people are trying to give the explanation, the mathematical expression for this absorption, the emitted by the black body. The black body is the object. Any object can absorb the light and emit. They are the perfect absorber and emitter. That's what the black body. This is a black body radiation. No, this is a quantization Planck's theory. So, in order to give what is the basic assumption in classical mechanics, I don't want to talk further on this because it will the basis of quantum mechanics. Okay. Now come to the picture. There will be a particle and a wave. I ask you, my dear students, what is the difference between scattering, diffraction or diffraction, or transmittance? Okay. What are the three difference between these three terms? Scattering, diffraction, transmittance. Okay. What is the difference? How many of you are aware of that very well? You have the stones, the bigger stones like bowling. Okay, the stones which is often be kept under the fish tank. The people are using the some color stones in the fish tank in order to showcase themselves very effective, attractive fish tank. When you take the particle, that is a stones, you scatter, you throw them. What is happening? Which is having the which is scattered through. You need to give some energy some velocity to throw the stone. Like cricket ball, you are throwing. Yeah, you have to give energy. If you throw very fast, then only the keeper will catch the ball and then hit the stone. If you slowly throw, the ball will not reach the keeper, then ultimately the extra run will run by the batsman. Though scattering, when you morning when you open the window, ultimately there are particles which is scattered. What is meant by diffraction? What is transmittance? See, if I am in the closed room, I am talking now. What is happening? I am sitting inside and I am talking. There are two waves. One is a sound wave, another one is a particle wave. Okay, light wave. What is happening? The light wave cannot go out, but the sound wave can go out. That is known as penetration. That is other way it is known as transmittance. So the sound wave can transmit other side, and then the people will hear what is happening, what Jacob is speaking now. My wife can hear what I am speaking, although she is sitting in the other room which is closed. But this sound wave can penetrate. That is known as tunneling. The smaller size they can tunnel and then they can go out. They can transmit from the wall. But the particle, if I throw this tumbler, ultimately it will not go out other side. So even the light wave cannot penetrate, cannot transmit. That's what you are studying the Tyndall effect. You know, the Tyndall effect is nothing but you have the colloidal particle where you are passing the light cannot penetrate out because the particle is scattered. Okay, the particle will not allow the light particle penetrate inside other side of the wall. This is known as the particle nature of the colloidal particle. The colloidal have the both the particle and the liquid, solid and liquid particle nature, so that they can have the penetration. So these scattering is property of a particle. The transmittance is a property on a wave can transmit, especially the sound wave. This is a diffraction pattern. You can see here, I can show you. These are all the famous scientists who invented a lot of things. The people are have the particle and the wave character. Even Thomas Young slit model. You can see here there are double slit experiment. There will be animation, which will give if you throw the ball towards a particular slit, then they can create the only the band like property. No, only one target where the ball can hit. But when you allow the wave into the double slit, it will create the band like geometry. This is what because of the diffraction, then the diffraction can create the interference pattern. One by one, they will interpret and then interfere, and then if the interference will appear like a wave. This is what the band like geometry. Okay. So these are all Maxwell wave, electromagnetic field, you know, uh, all the party. They are all eminent scientists where they invented the basis of atomic physics. What we are learning today, it's all the inventions of these scientists. Without them, we can't have the chemistry at all. Okay, the particle like nature of light, and then particle wave particle duality, the de Broglie. De Broglie is a layman man. Without this fellow, we can have the quantum chemistry. You know, lambda is equal to he only correlated wavelength with this is a wave nature. This is a momentum is a particle character. Okay, so what I am trying to tell you, my dear students, if you talk about wave, you should know what is wave, what are the nuances of frequency, wave number, wavelength, and then these all the aspect. So C is equal to nu into lambda. Nu is the frequency, lambda is the wavelength. When you take the wavelength, wavelength is nothing but electric and the magnetic field. They are mutually perpendicular to each other, and then the direction of propagation of light. So these electric and the magnetic field frequency is nothing but number of cycles per second. That's why it's unit called per second or hertz. That means if you take 1 second, how many frequency, how many cycles of frequency comes under? This is known as frequency. What is wavelength? The difference between the two successive crests or trough. Agadu or Mugadu. So the crest or trough. So that it is distance. So distance always in the centimeter. So that's why it is nanometer or centimeter. So nanometer is nothing but 10 power minus 9 meter. So what is wave number? Wave number is the inverse of lambda. So obviously it is a centimeter inverse. So if you take nu into lambda, so nu is nothing but per second. So this is a centimeter. So velocity all the time either centimeter per second or meter per second. This is what 10 power 8 meter per second or 10 power 10 centimeter per second. So these are all the basis of uh, chemistry, especially when you take electromagnetic wave. So when you take electromagnetic wave, so there will be a what is electromagnetic radiation? That is nothing but is it visible, my dear boys?
Yes, sir, it's visible.
Yes,
Yes,
sir,
sir.
visible. But time 12 to 17, sir.
Yes, madam. How much time is required? How
So
much
if you
time?
want, take the class, sir.
No,
If
I
you
will
want,
take
continue.
another 15 to 20 minutes. I will wind up. Is it okay, ma'am?
Sir?
Another 15 to 20 minutes.
Oh, okay, sir. Okay, sir. Okay, sir.
Now, as I told you, see, in every each and every action, so whatever we are doing in our life, we are always associated with the electromagnetic radiations. Okay, what are the electromagnetic radiations? You don't feel burdened by remembering this. I will simply comes under the FM. Some of you are very much interested in 93.5, 106.4. This is radio wave. Then another one, microwave. This most of them are interested in packing cake preparation. They have the microwave oven. Then another in phone. Earlier we have the Bluetooth. Before comes under share it or WhatsApp. We can transfer our photos, videos, songs, everything through Bluetooth. The Bluetooth is comes under IR. Then in 90s, people will use the camera and then they can have a photographic plate with the UV, ultraviolet radiation. Then within that, the visible region, and then they can have a X-ray, then finally gamma ray. The X-ray, we are taking the scan. Gamma ray is highly radioactive. Okay. Now with this, no UV visible. If you take the UV visible, you remember the rainbow, that is 380 to 700 nanometer. This is a VGR. This is what the entire. The radio wave, microwave, IR, UV visible, X-ray, and gamma ray. This is what electromagnetic radiations. People will give, this is a E is equal to H nu. As you remember, C is equal to nu into lambda. So nu is equal to C by lambda. So that HC by lambda and then HC nu bar. Now you come here, energy is always comes under joule, kilocal or calorie. And then frequency is always comes under per second. Lambda is always comes under centimeter. Wave number is always come under centimeter per second or nanometer. So this is what the entire concept where you can enjoy the chemistry. So nu is equal to C into nu bar. This is the other way. So you remember this concept. This is a fundamental. You can enjoy spectroscopy. Spectroscopy is all about you are passing the spectrum of light. So the light which is the monochromatic light. Mono means single. Chrome means there will be a VGR, but I am passing only the blue light. So the monochromatic light, you are passing the light into the molecule can absorb, and then either it can enhance the energy or reduce the energy, or there is no change. This is known as transmittance. These two are known as absorbance. So the absorbance is indirectly proportional to transmittance. You are passing the light I0, there will be I. So I0 by I is known as transmittance. I by I0 is known as absorbance. That's what absorbance equal to epsilon Cl. So you are passing the light into the solution that's having the concentration. Concentration always comes under moles per liter per mole. Sorry, moles per liter. Then the length, where the box, the centimeter. And then epsilon is nothing but liter per mole per centimeter. This is what the entire concept. Okay, my dear students, please feel free. You are passing the light into the solution. You remember, if you pass the solution into this pomegranate or apple, anything will happen? Anything will happen? The light will come in this side, that side? No. Obviously, we need to have the proper solution. That's why whenever we take the spectra, we need a solution rather than the solid or gas. The solution which should not be colloidal, which should be clear and not highly concentrated. It is a mild concentration, that is a low concentration. That's absorbance. You are passing epsilon Cl. This is known as absorptivity law. That is other way, it is invented by Beer-Lamberts. Okay, my dear boys, please remember this is a famous Einstein equation, Hc by lambda, Hc nu bar, Hc by lambda. This is what the entire chemistry, spectroscopy. Okay, as I told you earlier, microwave, radio, and then microwave, radio, IR, UV visible, and then X-ray, gamma ray. If you take radio, it's a NMR. If you take NMR, microwave, rotational spectrum. If you take IR, vibrational spectrum. UV visible, electronic spectroscopy. X-ray, that is XPS, AFM, all the things will come under. You can see here, you studied thermodynamics, in which you studied the very important principle called as principle of equipartition of energy. That is, other way it is known as law of equipartition energy. That is, the energy is divided into E vibrational, E rotational, E translational, E electronic. So other way also you studied degrees of freedom, number of independent variable to define the system. So these all together fold. The molecule, the electronic energy level, and then in which vibrational energy level, and then rotation. So S0, S1, V0, V1, V2, and then J1, J2. These two rotational, these two vibrational, these two electronic. That's why the degrees of freedom, first one translational, rotational, vibrational. You go with the formula 3n minus 5, 3n minus 6, where the 5, because the eta 3n, the n is the number of atom, 3n, so that is summation of rotational, degrees of freedom, vibrational, and translational. Translational is nothing but there are 3 axes the molecule can move, and so that the translational is 3. Vibration, we never know, we should know. Calculate. Rotational, the molecule can rotate along the 3 axes. But for linear molecule, they can have the rotation along the molecular axis, which will not create any difference. So that for linear 2, for non-linear 3. That's why for non-linear 3n minus 6, for linear is 3n minus 5. So that for all the atom, for example, if you have the sodium atom, which is having the 3 translational, there is no rotational 3, 0. But if you take hydrogen chlorine, there are 2 atoms, so 3, which is linear, so 3, 2, sorry. Three, 2, then there will be a vibrational, since it is a linear, 3 into 2 minus 5, so that what? This is what? Total degrees of freedom, 3, 2, 1. So all the things put together, my dear students, the way you are studying the chemistry, the essence or nuances, all the things, only the way you are looking the concept, that is very important. Before studying anything, try to know the basic concepts, the terms which you are going to study. Try to understand in your mother language. Okay, then you could enjoy the chemistry. So if you never try to understand all the things, reflection, direct transmission, absorbance, diffraction or refraction, all the things which will comes under the basis. The transmissions, as I told you, the reflection, which is getting reflected, what you are looking in front of the mirror, you are standing and then looking at the mirror and trying to get your own image. That is a reflection. The refraction, which will comes under and penetrate towards the other direction. So this is what the basis. The diffraction, as I given more information on this, and then the molecule can diffract. Scattering, this is the difference. So as I told you, all the basis which is comes under. So the polarization, the single plane along the propagation direction. This is what the polarization. Unpolarized, which will have the any direction, which will direction of propagation, which will goes any direction. These are all I discussed. What is a lambda, zero point 0.5, what is lambda, what is frequency, all the bases I have discussed. These are all the degrees of freedom I have mentioned for the water, 3n minus 6, because it is a non-linear. So that 3 into 3 minus 6, 9 minus 6, 3. So the three atoms, three vibrations I have given. Among the three, there are symmetric. There will be a bending vibration. This is a rocking and scissoring. And then these two are symmetric and asymmetric stretching. What is the direction in X, Y, Z? These are all the rotational motion. The molecule can rotate. As I told you earlier, how the molecule can rotate. See the linear molecule, the direction. This is a translational where the molecule can translate along the XYZ direction. This is a translational molecule. So as I told you in the beginning, these are all the spectroscopy aspect. And also I will come under a non-covalent interaction. Nuances means the basis also. These are all the non-covalent interaction, the ionic bond, the van der Waals, also the dipole, which is having the pi interaction, the pi bond, the hydrogen bonding. The majorly the hydrogen bonding is a highly electronegative element, fluorine, chlorine, hydrogen, oxygen. But in nature, nitrogen and oxygen can form the hydrogen bonding. That is a salt bridge in the double helix of the, and there will be a DNA double helix model, where there will be a stabilized by the hydrogen bonding. So AT and GC, they can have a 3 hydrogen bonding and 2 hydrogen bonding. They can form the salt bridge along the direction. So even our entire body, acid which is present in our stomach, which is have the hydrogen bonding, all the, if you drink the water, most of the reactions occur in the non-covalent interaction. That's why the entire cells, the stability of our cell based on the non-covalent interaction. So these are all the water, the most abundant cell in the living system, and then these are all the references, my dear students. What I conclude here, I wanted to conclude few things. This is a FTP, and also during the pandemic time, your faculty member put the lot of effort in making you to understand the chemistry very well. That's why I am trying to give my own experience. First thing, when you are a college student, you should capable of writing your own notes. Why your own notes? Because in school level there will be a books, there will be a blueprint. You have to write the way they set the blueprint. That's why you memorize and you return everything whatever you memorize. Like perfectly, it is a vomiting kind of system. But in college level, you have to study your own way and you have to develop your own learning skill. The teachers will teach you by referring so many books and try to give the hints, not the material. How to write the notes? I will tell you first of all in Tamil. In what way? Padithadil pidithadu. Whatever you are studying, you have to refer the standard books. Standard books. Okay. You have to now you don't need to choose only one book. At least you have to choose 3 to 4 books. Out of 3 to 4 books, you have to go through the particular concept and then you have to read very well. When you are reading very well, you may interested in catching some points. That is what படித்ததில் பிடித்தது. When you read, you are very much inspired on reading that one. Uh, that will be always remember in your mind. And then பிடித்ததில் whatever you interested, you liked very much. பிடித்ததில் அறிந்தது. Then try to know the fundamental. Then whatever you understood the basic, then understand. So படித்ததில் பிடித்தது, பிடித்ததில் அறிந்தது, அறிந்ததில் புரிந்தது. So அறிந்ததில் புரிந்தது. So the whatever you understand, you written something. That written material will be your notes. This is what the way we learn. So your material should be your own understanding. Your own understanding. So there will be a fact. You have to study and understand. Then it will become concept. Then only you can create the shortcut or ready reckoner or some of the shortcut. You can have it your own self. So the notes is not all about getting from my own faculty and try to read, because even though the material written by my own faculty, but the faculty which is written the notes, whatever she or he understood and she liked very much on the particular material, and she or he wrote the particular concept which is very much liked by them. So what I am suggesting you, if you are very much interested in studying chemistry, you have to prepare your own material by referring so many books. Then you will enjoy in learning the chemistry. Okay, so if there is a way, if there is a interest, there is a way. When there is a interest, if there is a need, if there is a need, there is a way. If you are not at all understood yourself, life is all about studying chemistry. If you study the chemistry, your life will be wealthy and healthy. That's what I can say. If you wanted to be very healthy and wealthy chemical life, you have to know the concept of chemical science, essence and nuances of chemical science. So that better you have to choose your own material by reading so many books. My suggestion, during this 21st century, even I am myself are very much addicted to using mobile phone, technology oriented people, but we are not even ready to refer so many books. My own students are not ready to go through any of the books. They never know even single book name. They will get the material from the faculty member and try to study. How do you understand? Because it written by me, whatever I understood. Okay, so please, with the new year beginning, this is the 4th of the January 2022. I wish you very happy, prosperous new year to all of you who attended this lecture. I wish you all the best to have the happy, prosperous, joyful New Year yet, without having any kind of uh, lockdown or curfew in the upcoming year. God bless you, all of you. I wish and pray for all of you for your good life, future life with wealth and a healthy life. Thank you for listening one another. Thank you.
Yes, sir, for sure. Well, sir, you may be disappointed about offline presentation, but we really felt your session is highly lively with understandable comparison and examples. Even a non-chemistry person like me able to grasp the concept in a clear manner. The points like chemistry is given take policy and the importance of 119 elements in chemistry, the importance of atomic physics, and importance of electromagnetic waves, and finally the special conclusion note you've given to our students. These are all really valuable to us. Thank you, sir. Thank you for a great session. Now I request Dr. S. Srinivasan to honor the program and everyone with a gratitude note. Srinivasan, sir.
Yes, ma'am. Thank you, ma'am. I am audible, ma'am.
Yes, sir.
I am audible. Yes, yes, okay. Good morning to all. It's my pleasure to deliver a vote of thanks in this wonderful occasion. I express my deep sense of gratitude to the management for permitting to conduct the faculty development program. I would like to thank our chief guest, Dr.M.Jaccob, Assistant Professor, DSF Inspire Faculty, Young Scientist, Loyola College, Chennai, for his willing acceptance and enlightening us with his knowledge. Thank you, sir. I thank our principal, Dr. V. Nakojodi, and Vice Principal, Dr. Hen Sujata, for their constant support and encouragement. I'm glad to thank our head, Department of Chemistry and Science Club Coordinator, Dr. G.P. Bhavani, and IQAC Coordinator, Dr. C.P. Prakash, for arranging this wonderful faculty development program. I'm happy to express thanks to all the participants who have made this program a great success. I once again thank everyone for making this program successful. Thank you very much all. Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
ma'am.
sir. Thank you,
Now you
sir.
can leave the studio, sir. Thank you, sir.